Today we're going to talk about using evaluating integrals using tables or charts, lists of integrals. So it's very important that you know how to do these integrals on your own. That ability to come up with an integral, very, very important. So make sure that you know how to do everything by hand. However, there are some situations where there are some fairly involved integrals that look kind of ugly. And so in the past, people have already worked through these, and there are lists that are readily available so that you can just reference them. So there's a bunch in your textbook, either in the front cover or the back cover, somewhere in there in the index, whatever. You can look these up online. But being able to use these common equations and these common integrals or known integrals in the formulas to go from your integral to solving it fairly quickly is also a nice skill to have. So, for example, let's go with this. We know that the integral of u squared divided by the square root of a squared minus u squared du is negative u over 2 square root of a squared minus u squared plus a squared over 2 arcsine of u over a, and then don't forget your plus c. Now let's use this to evaluate the integral of x squared over the square root of 5 minus 4x squared dx. So is a squared, so a is going to be square root of 5. Yeah, it could be plus or minus. We'll just stick with the plus. U squared, and it's a little bit easier to, or a little bit better to pick the one down there, is going to be 4x squared. So our u is going to be 2x. Again, we're just doing the positive one. So now in order for this to work out, we have to make a few little changes. That our u squared is 4x squared. But up here, we don't have that 4. So we need to put a 4 in there. But that's going to change our equation. So we have to compensate. So we need to divide by it. So eventually, basically have a 4 divided by 4, which is a 1. So we're not changing it fundamentally, just the way it looks. But now another important thing to remember is your dx. So our du here to make over here. So now what we have here is going to match up with our general form, and we have a little bit of a compensation factor out front. So we can have this 1/8 out front, a negative u over 2 square root of a squared minus u squared plus a squared over 2 arcsine of u over a plus c. And we need to slide that and close our parentheses. And now we can do some simplification. These 2's are going to cancel. We could rationalize that expression inside the arcsine if we wanted to. We could distribute that 1/8 to everything. So a few ways we could manipulate our final result, but the idea is to recognize where are your u's, where are your a's, getting your original equation to match that, so we can just use our known integral to go ahead and solve this. And now you could approach this one by hand too, that this bottom is set up as a nice trig substitution. So you could make your u a square root of 5 times sine, and then go through the whole process of your trig substitution. You know what the result. Let's do another one. Let's say that we have the integral of du over u squared minus a squared is 1 over 2a natural log absolute value plus a plus c. And this is another one that's fairly easy to verify. Do your trig substitution with your u equaling an a secant of theta or secant x, whatever you want to call it. And let's use this one. It's 9. And we will go with 5x on top. Squared is 9. So our a is going to equal 3. Again, just going with our positive one. U squared is x to the 4th. So our u is going to equal x squared. But now our du is our 2x dx. Now we have our x dx in there, but not the 2. So let's multiply a 2 in front, and then we would need to divide by that 2 to compensate. Move that 5 out front. So rewriting this, we get 5 over 2 integral of 2x dx. So if you want to combine those together to emphasize your du, and then it's going to be an x squared squared minus 3 squared to make everything match exactly as we have it in the original equation. And now all we have to do is use that equation. That's a 1 over 2 times a, although don't forget your natural log absolute value of u minus a over u plus a plus c. Make sure this actually looks like 5 a bit better. Natural log x squared plus 3. And then plus, it should be a 5 halves c. We'll just call it k. It's not going to do any good. We can't factor the bottom to cancel anything. You could use your laws of logarithms to split this into 2 logs and do subtraction, but that so that's our basic idea. We want to individual expressions inside of our logs, inside of our integrals, and we want to find an integral that's similar to it. Then manipulate our integral so that it matches. There might be some numbers that are out front. That's okay. But then we can use what is known to make our life a little bit easier. And in the real world, you're not always going to be given integrals that are going to work out very nicely. So having the ability to reference other people's work and known integrals, that can be a tremendous time saver than having to do it by hand. Or if you're working through the homework and you want to, or doing practice problems or other things, you can come up with some equations, or if you're given equations in the book, work through your answers and it help you out with that. I would not rely on the tables too much because whenever you're given tests, you're going to have to do a lot of this by hand. So you're not going to have those tables. But the ability to use the tables is very important.